Welcome to Summarize Science. When you get a list of chores, you probably don't just do them one by one in the order they were given. You try to be efficient, like starting the microwave and then wiping the counter while you wait. However, for most AI-powered robots, this kind of simple efficiency has been a major challenge. Existing systems often tackle tasks sequentially, which, as this diagram shows, is incredibly slow. This paper introduces a way to teach robots to think more like us by using something called operations research, which is basically the science of optimization. Instead of taking 73 minutes to do these kitchen tasks one after another, the AI learns to create a schedule that gets it all done in just 39 minutes. That's a massive 47% faster. The AI learns to identify tasks that can be started and left alone for a while, like cooking food in a microwave for 35 minutes. It then intelligently fills that waiting period with other tasks, like washing the sink and wiping down the coffee maker. To teach this new skill, the researchers had to create an entirely new, large-scale dataset called ORS-3D60K. As you can see in this table, compared to previous datasets, it's the only one that incorporates this special operations research knowledge needed for efficient scheduling. It contains over 60,000 complex tasks spread across thousands of virtual 3D scenes, giving the AI a massive training ground. The AI model they created is called Grant. Here's a simplified look at how it works. First, it takes in a 3D scan of a room and the text instructions for the chores. The model's language brain reads the instructions and identifies which tasks are parallelizable, meaning they have a waiting period. Then, a special scheduling token calls an optimization solver, which acts like an efficiency expert to create the fastest possible plan. Finally, the model generates the step-by-step actions and knows exactly where each object is in the 3D room, thanks to its grounding head. So, how well did it actually work? The results are pretty clear. Looking at this comparison table, the Grant model significantly outperforms other methods in time efficiency, or T. It scored nearly 73% on time efficiency, while the next best scene-level method was only at about 42%. This shows that explicitly teaching an AI how to schedule tasks makes a huge difference. This example shows the system in action on a very complex 7-part task. The model correctly identifies that operating the microwave is a 30-minute task with a long waiting period. It then builds a schedule to complete several other chores while the microwave runs, saving 29 minutes compared to doing them sequentially. So, let's recap the important points. Researchers have identified that current robot agents are inefficient because they perform tasks one by one. They created a new model called Grant that uses operations research to create smart, parallel schedules. To do this, they also built a massive new dataset, ORS-3D60K, to train the AI. The result is an AI that can complete a complex list of chores nearly twice as fast. This is a crucial step towards creating robot assistants that are genuinely helpful and practical for our everyday lives, turning science fiction into a much closer reality.